Okay, so for problems like this, you kind of got to start inside the parentheses and just kind of unravel it a little at a time. There's like 3 different things to do here. First of all, we're thinking, um, they said find the value without using a calculator. So we're just going to assume that we're just talking about first quadrant angles here, just because they didn't say, they said find the value. That sounds like one value. So we're just going to assume first quadrant angles here. So I'm going to copy this, bless you, I'm going to copy this sign on the outside, bless you. Bless you, it's that time of year, isn't it? I woke up with sore throat this morning, and I'm not usually having those kind of problems. So what this right here means, what's the angle that has a sine value of a half? Sine 30. Okay, so this, we'll work in degrees just because it's easier to think. So what I'm going to do here is we're going to replace that with 30 degrees. Now we're subtracting the angle whose cosine is a half. So what has a cosine of a half? 60. Okay. So what we're going to do here, we could put sine negative 30 degrees here and go find that, or we could use the difference formula. Let's go ahead and use the difference formula just because these values are pretty easy to get. So what we could do here is say, all right, the difference formula, let me make sure I get all my signs right on it. Sine of u minus v, I'll kind of write it in red over here. Sine, it's not picking up, of u minus v from the formula is equal to sine u cosine v minus cosine u sine v. Okay, so we're taking the sine and the cosine of each one, and then we're going to switch which ones we take the sine and cosine of, and do some subtraction here. Okay, so what's basically going to happen is I'm going to have 2 values minus 2 more values. Okay, so sine u is your first one. It'll be your 30 degrees. Sine 30 degrees, we already knew was a half. And then we're supposed to take the cosine of 60. Well, what's the cosine of 60? It's also half, isn't it? So right now we already know that's a fourth if we just wanted to go ahead and simplify there. And then 60 degrees. The sine of 60 degrees is, wouldn't that be square root of 3 over 2? Yeah. And the sine of 30 degrees would be square root of 3 over 2. And if you multiply square root of 3 times square root of 3 on top, wouldn't we get 3? And on the bottom, we'd have 2 times 2 is 4. And a fourth minus 3/4 would be negative 2/4. And that would reduce to negative 1/2. So instead of outright giving you the angles, they even complicated this a little bit more by making you work even for the angles that you were going to plug in the formula there a little bit. That's kind of what they were trying to do, was up the level, difficulty level 1. Okay, so this arc sine and this arc cosine, they're telling me find the angle who has a sine of x and find the angle who has a cosine of x, right? That's what arc cosine means. It means I'm trying to find the angle. So they're kind of doing the same thing on this one as we just did on 51. They're making us work for the angle a little bit here too. So here's the deal. All I know is that the value is x, so I got to go draw a right triangle. If I don't know what else to do, I should draw a right triangle. Because if the angle, if the value of this angle here, we'll call it, I'll just call it theta. I don't know if that's going to show up as anything but a blob on the iPad, but I don't know what it looks like, a half moon or something. If the value is x for sine, sine is, if you think about SOHCAHTOA, isn't it opposite over hypotenuse, right? So the opposite from this would be x, and the hypotenuse would be 1. How can I find this other side over here? Yeah, we'd have to say, I'd have to do the Pythagorean theorem over here. Let's see. This side over here would be 1 squared equal, let's call it, for right now we'll call it a. Well, yeah. Wouldn't that just be the square root of 1 squared, which is 1, minus x squared? if I could do that. Okay, so and then so what would be the arc sine? Oh gosh. Next thing, let's go do the cosine one here. I'll underline it in red just so we can see which triangle goes with which expression. If I've got an angle here, I'll call it phi. I'll just put a line through it, though it looks kind of the same. If the cosine is x, cosine is adjacent, so that would be this side over hypotenuse, right? So this other side would be the square root of 1 squared minus x squared, which would be square root of 1 minus x squared here. There's no way we can represent that angle. We can't pop a number out for this angle, can we? There's just no way we know this. So what we have to do is think, okay, I'm going to use that formula, and the formula, if this is u plus v, it's sine u cosine v plus cosine u sine v. So we don't really know how to represent these angles, but the thing about it is I can fill in each one of these values by looking at these triangles here. So I had to go draw the triangles because I'm like, how in the world am I supposed to do that, right? We don't know a lot of information there. What's probably going to happen here is we're going to end up just with an expression just with x's in it, or maybe everything is going to cancel out and be 0. Who knows? Okay, here we go. So sine u, this top one is the u. I should have put a u and a v there, I guess. Sine would be opposite over hypotenuse for this first parentheses. Wouldn't that be x over 1 for opposite over hypotenuse? So I'm going to write x over 1 here. I still don't know what the angle is, but I don't really care because I can split it up like this. Now cosine of v, that's the second triangle down here. The cosine is the adjacent over the hypotenuse. Wouldn't that also be x over 1? So I'm going to write that there. Okay. So now we're on the other side of the plus side. The cosine of u, that's the top one. Cosine is adjacent over hypotenuse. Isn't that going to be this square root of 1 minus x squared over 1? So I'm just going to write down square root of 1 minus x squared. Oh, wait a minute. Yeah, that's right. I thought I got it off the second triangle, but come on, get rid of that line. All right, the sine of v, we're on the red triangle now for v. Sine is opposite over hypotenuse for this one right here. Well, opposite is square root of 1 minus x squared, and hypotenuse is 1, so we don't need to make a fraction out of it, right? Okay, so does everybody see what we did so far? We took the information inside of here and drew a triangle for each of these cases and used the Pythagorean theorem to fill out the third side. We got around not knowing the angle by being able to express these sines and cosines of it because we had all the sides, and so we just took the different ratios and plugged them into this formula here. And we're still not going to know the angle, but we're not really going to care because now we can simplify and at least get an expression. X times x is x squared, don't need the fraction, plus square root of 1 minus x squared times square root of 1 minus x squared is 1 minus x squared. I could put it in parentheses, but since I'm adding it, I don't care. What's it going to be? 1. So the sine of whatever that was 1.